Welcome to the Virtual Foundry podcast.
Hi, everybody. Welcome to the Virtual Foundry podcast. This is Volume 4, Episode 8. Today is Friday, August 18th, 2023. The time is 1:48 in the afternoon, and the temperature is an absolutely lovely 76 degrees Fahrenheit. That's 24 degrees for you Celsius users. It's unusually cool for this time of the year, especially being mid-August. We're used to it being very, very hot. So these temperatures are a welcome change for me personally this year.
Agreed.
I'm Tricia Cease, president of the Virtual Foundry, and with me as always is Brad Woods, founder, inventor, and all-around science guy. Say hello, Brad.
Hi, everybody.
Now, Brad, today we're going to be talking through a case study. The case study is a flange adapter, and this happens to be a part that we use right here at the Virtual Foundry in the machine that we use to make our Filamet metal, glass, and ceramic 3D printing filaments. Now, this part is a flange adapter that connects a hose to an extruder machine. Now, let's take a look at the part. So what we're seeing here is a slide from our Ideal Applications webinar that we did recently. This might be a good webinar for you to watch if you're wondering if this technology will be right for your application. Click on the link at the top of this video and you'll get to that webinar recording. Now, this slide is showing the part being printed, the green part, the sintered and polished part, and then finally the part on the machine. And we'll be taking a closer look at that in a minute. Now, this part is about 4 inches square. That's about 100 millimeters square. And Brad, I have many questions.
All right, bring it
First
on.
of all, what were you using for this part, this flange adapter, before you made this one?
It's actually a little bit embarrassing. We struggled for a long time and would kind of just put something together on the fly as we were setting up, whatever it took. It tended to use some PVC pipe and some duct tape.
Now, yes, obviously that's not a long-term solution. So you went to 3D printing and 3D printing with Filamet to create a more long-term solution. How was this part designed since you were starting from nothing?
Right. So I simply walked over to the extruder with the caliper and a notebook and just took some quick measurements. One of the things here, so we couldn't use plastic on the throat of the extruder. It'll hit about, as high as 200 degrees Fahrenheit. So that PLA wouldn't work, which is why bronze is such a perfect solution.
So you designed the part in Tinkercad?
Yeah. Here, let me share my screen. Yeah, so it's just this simple. It's just the very basic shapes from Tinkercad, some cylinders, some a series of holes. You can see that it's 90 by 95 millimeters, 23 millimeters tall. And yeah, so this likely took, I'm pretty sure it took me maybe an hour and a half. And I've actually gotten better with Tinkercad since then. So I suspect it would take me even less time at this point.
Great. Now this part is very flat and kind of wide. Did you do anything special during the sintering, during the debind and sintering process to make sure that that bottom stayed nice and flat?
Yeah, so since I wanted it to be absolutely as flat as possible, I set it on a piece of graphite. So just graphite that you might normally use for machining or something like that. I always keep it around the shop because it's handy in cases like this. So I set the piece, it's centered as it's used, with the hole facing up. And yeah, I just put it on a piece of graphite and then buried all that in carbon and centered it in place.
So you're still using the same general process that we list on our website. You've got a crucible, you've got your refractory ballast, But one thing that you did to help keep this part nice and flat was to lay it on a flat surface inside that crucible, inside the ballast.
Correct.
Great. Now those fastener holes, tell us about that. How precise did those fastener holes need to be?
Right. So the part shrunk by 8% after it was sintered. And this isn't a very high precision part, obviously. So I just left myself plenty of space and decided that if the holes were too big, I would just use a washer or something like that to attach it to the extruder. So there's not a lot of precision here. And I just designed in margin of error so that I was sure that I would get something that I could use on the first try.
And if you had printed your holes a little too small, it's easy enough to drill those out post sintering. Anything that you would do to metal normally, you're doing to these parts that we've 3D printed and then sintered.
Yeah, you can grind it, you can cut it, whatever you need to do. If we have multiple components, I like to use silver solder to attach them. It's nice, high temperature, and a really, really hard braze, basically. And it's a sheet of metal, so if it gets bent or something like that, I put it on the anvil and hammer it back into shape.
Now we're used to seeing machine parts in steel. Machines are generally made of steel. Why is this one in bronze?
Bronze is so much easier to print and sinter. Not so much the printing part, but sintering bronze or any of the copper alloys or copper is just way, way easier than steel. Steel tends to oxidize, and it sinters at a much higher temperature. So this part was sintered at 1575 Fahrenheit, and I'm not sure what that is in Celsius, which is relatively low. I mean, pretty much any common kiln can hit 1575 Fahrenheit. And there's a lot of people focus on needing to print steel, and we encourage them to consider whether bronze is a reasonable substitute. Bronze is strong and easy to work with, and perfectly applicable in most cases that steel is currently being used.
Okay, well, we went out to the field and took a video of this part in action. Let's take a look.
Hi, this is a part that we made for our extruder. So this is made out of bronze. It's printed on an Ender 5 or an Ender 3, I can't remember, but printed or designed in Tinkercad, which took maybe an hour at the most, and then 3D printed. The printing probably took another hour and a half to 2 hours, and then it was sintered in debound one day and then sintered the next. And here, I'll show you what I'm talking about. So this is just a very simple flange adapter. This is our extruder, and this is the feed where pellets go into the extruder. So this piece, incredibly useful, took, like I said, took a day or two to get it put together and completed, and we've been using this for about 1.5 years, maybe 2 years now. So plenty durable, very strong, did its job, works perfectly. And it tolerates a fair amount of heat. It gets up to nearly 200 degrees Fahrenheit right here at the throat of the extruder.
Great. So we can see you gave us a little bit more information about designing it, printing it, going through the debind and sinter process, which is a 2-day process. So really from idea or need to part in place, it was a 2-day process.
Yeah, and this is a simple part, but it isn't something you can go out and buy. There are no off-the-shelf components that look like this. So very easy to design, very easy to print and sinter, and very useful. Like I said, it's been at least 1.5 years that we've been using it, and the finish is held up. That's just what it looks like. It hasn't been maintained in any way. That's just the finish that it has after 1.5 years.
Now, to get it to that shiny finish, you did do some things to that centered part, and we'll post a link to the part cleaning podcast that we did to give more information about that. So you can check out those techniques for yourself. They don't come out of the sintering kiln that nice and shiny. So there was some effort put into that. You can watch that video for more information about that. Another really nice benefit about using this technology for a part like that is that if the part breaks, it's very cheap and easy and a short time frame to get another one. So another 2 days of print, debind, sinter, and you've got another part in action. So machine downtime is very minimal, and it's also easy to make some backup parts so that you could experience no machine downtime at all.
Yes. And this video is intended to show something that's very simplistic and basic. So I intentionally left large margins of error in aligning the holes and things like that. But you can get to a much more precise part than we're showing here. And just to clarify, they come out of the kiln dull. So that one was finished with a brass wire wheel on a bench grinder. And then just a sewn cotton buff and some buffing compound. So total finish time was less than 10 minutes.
And that's only required if you want it to look pretty. If aesthetics are not important to the purpose of the part, you wouldn't really need to go through any of that.
No.
But we've really liked this part around here. So Brad made it look nice and beautiful for being able to show off.
And the funny thing is, actually, over the past year and a half, we've been trying to think of useful functional parts that we could talk about in a podcast. And I completely forgot that I had made that one and it had actually been in use.
Well,
So,
it's just been quietly working great this whole time.
right.
Now, Brad, before we wrap up today, I do have one more very important question for you.
All right.
Did you see that show about metal fasteners?
No.
It was riveting.
Nice.
Now, listen out there, if you've got a 3D printed part that you are using and it's made out of metal with the Virtual Foundry's filament, let me know. Let's get you on a podcast. We'd love to see what you are up to and show you off a little bit. If you've got a question that you'd like us to do a deep dive in this format, let me know too at info@thevirtualfoundry.com. We would be happy to do a podcast with or for you. Make sure to like and subscribe the video on YouTube and check us out on all the awesome social media channels out there, and come into the Virtual Foundry's Discord server. You'll find a lot of other folks in there working with Filamet metal filaments. You can ask questions, kind of see what others are up to and what they're talking about. It's a great place to join the community around FFF Metal 3D printing. That's all for now. We'll see you next time. Happy printing, everybody.
Thank you.
The time is 3. Just a second. I had one more question.